Hello everyone, thank you for checking out this video. You are with Coach Barrett from Math Academy. Right now, we are going to solve these questions together. Okay, so let's look at the first question first. So in the first question, it says that we want to find the last two digits in 2 times 2 times 2 for 2023 times. Okay, so how do we solve this question? Okay, usually what we want to do is to use number patterns, right? So the first thing you want to do is to list out some of the numbers first. So the first thing first, we'll list down the first number, which is 0, 2, right? The last two digits. So for the first one, it will be 0, 2. Next, we just have to multiply by 2 for the next number, right? We will get 0, 4. Okay, so 4, we multiply by 2 again, we will get 0, 8. Okay, so we will just keep going down the list until we start to see a pattern. Okay, so 8 times 2, we will get 16. 16 times 2, we will get 32. Okay, and we will just keep going on the list until we find our pattern, right? Until we find whether there is any pattern. So we have 64. So what happens after 64? You realize that when you take 64 times 2, okay, you will get 8 here. 6 times 2, we will actually get 12. But we don't care about any other digit. We only care about the last two digits, right? So we'll get 28. So we'll just keep doing this, right? So 28 times 2, we get 56. Same thing. So 56, you will just take 56 times 2, right? So we will take 12. And then realize that you will get 11. But we don't care about anything else other than the last two digits. So we'll get 12 here. 24. So we will want to keep listing down until we find a number pattern, right? So we'll just times 2 again, times 2, times 2 again, until we find a pattern, okay? So we have to do this as fast as possible, okay? And see whether we get any pattern. So far, we have not found anything yet. So, okay, what happens next? After 52 times 2, right, we get 104, but we're only placing the last two digits, okay? So we got 4, and we got 8, and we got 16. So do you see over here that the number pattern 0, 4, 0, 8, and 16 has started to show itself? So can you see that we are actually managed to find some pattern already? And you see that the pattern is that we will start from the first number, which is 0, 4, right? And then it ends at 52 before it repeats itself again over here, right? So if you count the number of numbers, right, in a certain set in this pattern, you realize that you actually have 20 numbers in one set, right? So you realize that you have 20 numbers in one set. So what should you do next? Okay, since we have 2023 numbers in total, right? Okay, the first thing you want to do is to take 2023 minus 1. Why do we minus 1? Because you realize that actually this first number, 2, right, is not part of any set. You see, the set always begins with 4. So we need to minus 1 first. Okay, so we minus 1, we'll get 2022. Okay, so we take away the first number. So what happens next is that we want to take 2022 divide by how many numbers in one set. Okay, so we need to first divide by 20 to get how many complete sets of numbers. Okay, so 2022 divided by 20, we will actually get 101, okay, remainder 2. Okay, so what does this remainder 2 stand for? So basically this remainder 2 represents the second number in any set, right? Because this is the first number in any set, and this is the second number in any set. And since we are left with the remainder 2, we are left with the second number in any set, okay? So therefore, the last two digits, right, would be 0, 8, okay? And this is the answer. Okay, so now let's look at question 2. So question 2 says that we are looking at a right-angled triangle below. Given that BC, right, is 13 cm and AC is 12 cm. So we want to find the area of triangle A, B, and C. So the method that we will use to solve this question, right, would be using Pythagoras theorem. Pythagoras theorem. Okay, so the first thing, right, is because we know that we want to find the area of a triangle. So we know that the formula, right, is to get half times the base times the height. So over here, what is the base? So we know that this base, right, can be AC, right, the base, and the height can actually be AB, which is 12 cm. Okay, so we have the height, very good. Okay, but do we have the base? We don't, right? So in order for us to find the base, this is where Pythagoras theorem comes in. Because in Pythagoras theorem, what it states is that basically our AC squared plus our AB squared, this will give us BC squared. So basically Pythagoras theorem is the square, the summation of the squares of the two shorter sides, right, will give us the square of the longest or furthest length. Okay, so right here, let's fill in the blanks, right? So we know that AC is the base that we're trying to find, okay, and AB over here is 12 cm, so it's 12 squared, and then BC is actually 13, so we put in 13 squared. Okay, so we just want to solve for what is the value of B. Okay, so let's move everything to the right hand side. We only left B on the left hand side. Okay, so we have 13 squared minus 12 squared. This will give us B squared. Okay, so in order for us to just get the value of B, right, we have to square root on both sides. Okay, so we have 13 squared here minus 12 squared, and we need to square root this whole thing. Okay, so then we would be square rooting. What is 13 squared? 13 squared is actually 169. Okay, and what is 12 squared? 12 squared, you can work it out to be 144. Okay, so 169 minus 144, this will give us 25. So we know that square root of 25 would actually give us 5 cm. Okay, so once we are done with this, we can immediately put it into our equation to find the area. Okay, so the area would be equals to half times the base, right, which we found is 5 cm, and then we times by the height, and the height we know is actually 12 cm. Okay, so we know that 12 can be divided by 2, so we can get 6 over here. So 5 times 6, we would get 30 cm squared. Okay, so very good. Now we have found the area, and this is the answer for this question. Okay, so let's look at the next question. Okay, question 3. So in this question, it says we need to find the value of n, right? N is over here in this whole equation. So what is this equation? This equation is basically saying we are doing summations, right? From 1 plus 2 plus 3 all the way until our final number, which is n. And this summation would lead us to 780. Okay, so how do we solve this? It is simply by using the Gauss method. Okay, so how do we do this question? So if you recall the Gauss method, right, basically, for example, right, if we are doing a summation from 1 plus 2 plus 3, you know, all the way until 100, for example, okay, what would be the answer? Usually we can use this, we can solve this, right, using Gauss method very easily. So the first thing that we want to do is to always find the sum of one pair. How do we find the sum of one pair? Remember, this is something like a rainbow, right? So we will match the first and last number together, and every other pair we can match it like this, like a rainbow. Okay, so you will realize that the sum of one pair, right, for the first and last number, this is 101. Okay, so maybe I put here 100 plus 1, right? We will get 101. What about the other pairs? You realize that we have a 2 and a 99 as the next pair, right? And you realize that 2 plus 99 would still give me 101. Okay, so this means that every pair that I find would give me a sum of 101. Okay, so great. Next. So after we find the sum of one pair, what do you realize? You realize that because each pair, right, is 1, 0, 1. So how many pairs are there in total? How many pairs do we have? Okay, so we need to find the number of pairs next, right? So can you see that in order for us to find the number of pairs, maybe you can see that over here is 100, correct? 100 numbers, we have 100 numbers in total. So in order to find the number of pairs, right, we need to take 100 and we divide by 2. When we divide by 2, we will get 50 pairs. The reason why we divide by 2, right, because we are pairing the 100 numbers together, okay? Pairing the 100 numbers together, so we have 50 pairs. So the last step over here to find the answer, right, is to just take these two numbers, 101, multiplied by the number of pairs, and we will get our summation, which is 5050 in this case. Okay, this is basically what Gauss method is about. So we will use Gauss method for this question. So the first thing we want to do, same thing, right, is to take the sum of a pair. So we know that, like we said just now, we can take the first and last number, right? We add them up together, and that is the sum of one pair. So we have n plus 1. Okay, the next thing we want to do, same thing, we want to find the number of pairs. What do? We take the largest number and we just divide it by 2. So the largest number in this case, right, in this question is actually n. Okay, it's actually n. And then we will divide this by 2, okay, because we are looking at total numbers we have, we divide by 2 to get the number of pairs. And then this would be equals to 780. Once we get 780, right, we just want to solve for the value of n. So the first thing we can do is to actually multiply by 2 throughout to get rid of the denominator on the left hand side, right? So once we multiply by 2, we are only left with this expression on the left hand side. And then on the right hand side, we're looking at 780 multiplied by 2. Okay, so we get 1560. Okay, great. So once we reach here, right, actually what we want to do is that we can try and estimate some numbers, right? Because we know that actually n plus 1 and n are actually two consecutive numbers. So let's say if n is a number 30, then n plus 1 would be a number that is 31, right? So you realize that you can actually try out many different numbers, right, and see whether we get 1560, or we can start to estimate, use very logical estimations, right, to make sure that we get the answer, which is 1560. So over here, since n plus 1 and n, right, are two numbers that are very close to each other, we can actually use n times n and use this to help us approximate to get our answer 1560. Okay, so you realize that you can actually just make use of square numbers first and then see how close we can get to the answer. So maybe let's try 10 times 10. Okay, so 10 times 10 is only 100, so this is too small. Let's try 20 times 20, for example. We get 400. Okay, this is still way too small, right? So let's look at 40 times 40. Okay, so 4 times 4 over here, we will get 16, right? And then you will add 2 zeros at the back because of the 40 times 40, we will get 1600. Okay, so once we get 1600, right, you realize that this is actually very close to the answer. Okay, so in fact, you are only 40 more than the actual answer actually. So 1600 is 40 more than the actual answer, right? So this means that what if I reduce from 40 times 40 to become 40 times 39, right? Because we are just 40 away from the actual answer, so we reduce it by 40. Okay, so 40 times 39, we will get 1560. Okay, so once we get 1560 over here, you might realize that your 40 is actually your n plus 1, right? And n is just 39 because these two are consecutive numbers, right? One number after the other. Therefore, your answer for n, right, is actually equals to 39. And this is your final answer for this question. Okay, so now let's look at question 4. So for question 4, we are asking for how many triangles, right, can be formed using 3 points as their vertices, okay? So 3 points as their vertices would mean, example, this is 1 point, the second point, and the third point, and this would form one triangle. So you can see that there are so many possibilities, right, that we can form as many triangles as possible, okay? So to tackle this question, we actually have to organize ourselves, right? So let's call this line as line 1, and you need to call the second line over here as line 2, okay? So the first thing you want to do is to let line 1, right, be the base of a triangle, okay? So we want to let line 1 be the base of the triangle first. So what does this mean? This means that if I call line 1 as my base, right, so you would see that line 1 would have 2 points, and line 2, right, which is the tip, would only have 1 point. So when you match up the points or the lines together, you would have one triangle like this, right? So the strategy here, right, would be to move this point first across the other points, okay? So you would see that firstly, we would have joined this over here, okay, for one triangle like this, okay? So you see that over here I have one triangle already, plus one more when I move it to the right side, right? So that we have a total of 2. Let's move it again. Now we have a total of 3 triangles. And then now we have a total of 4 triangles, right? So we have a total of 4 triangles so far. So what do you see? Is that you might realize that if I start with this point, the number of points on my right hand side, right, would determine how many more triangles I can get, right? So since we have 4 more points, we would have 4 triangles, okay? So we are not done yet. Let's move this point, okay, to over here. Let's move it forward like this, okay? So once I move it forward, let's match the 2 points up first, okay? So you might realize that we need to continue counting how many triangles we can create, right? Okay, just creating as many triangles as possible. So you see that this is maybe one combination that you can do. We must always look at it on the right side. So you might see that this is the one triangle, the second triangle, and this is the third triangle, okay? And the reason why we cannot use back this triangle over here, okay, let me erase this first. The reason why we cannot use back this triangle is because, do you remember that we actually looked at this triangle in our first working, right? Remember we used this triangle before, so you need to make sure that there are no repeats. Okay, we do not want to repeat. So that is why we always look on the right hand side. Okay, look at how many points we have on the right hand side. So you see that we have 1, 2, 3 points in total. We will make 3 triangles. Okay, so we'll just keep repeating this, right? So we have to move this point now forward to the point over here, so we can match the triangle, right? So we don't have to think about it too much anymore. You just have to realize that on the right hand side of this point, we have 2 more points over here. So you then becomes a +2, and then you realize that actually your summation is just from 4 all the way down until we have 1. So if I move this point forward, you realize that how many points do I have on the right hand side of this point? This is just 1 more. So this is the last one, okay? We are done with this portion, but do you realize that actually we have more combinations if we look at changing the tip of this triangle, right? So if we change the tip of the triangle, for example, so this is one that we can match up first. So this is one triangle that we have found, right? So sorry, this is one tip that we have found. So let's say if we cycle through the different tips of triangles, right? So we have here, and then we can cycle throughout again, here, 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 and here again. Then you realize that this whole thing would actually have to repeat for 6 times. Okay, this would actually have to repeat for 6 more times. So what is the sum of 4 plus 3 plus 2 plus 1? We would actually have 10. So what is 10 repeated 6 times, which is times 6, right? Would actually get 60. Okay, so that is only for the first line. Now we need to repeat for the second line. Okay, so now let's make line 2 our base of the triangle. Okay, so if we let line 2 be the base, right, what would it look like? That means my line 1 is only 1 point, and my line 2, right, would have at least another 2 points, right? Okay, so you only have 2 points, line 2. Okay, so this would be our first triangle, correct? So same thing, we would keep moving this point, okay? Moving this point here, 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 and here. Okay, so same thing, right? You realize that you have 1, 2, 3, 4, and 5. So every time we are looking at the right side of this point. So we have to start with 5 over here. So same thing, right? If we move this forward to come here, move that point forward, right? So we will also have to look at how many points do we have on the right hand side of this point, which is 1 triangle, 2, 3, and 4, right? Same thing. And we don't count any repeats. So you actually realize that you are doing the same exact thing, and you will sum it all the way until from 5 to 1. Okay? And let's see how many times this repeats, right? So remember just now, the number of times you must repeat is based on the tip. So now how many tips do we have? We have 1 point, 2 point, 3, 4, and total of 5 points that we need to repeat. So you need to multiply this by, repeat this by 5 times. So we have 15 times 5, because 15 is over here. 5 plus 4 plus 3 plus 2 plus 1 is 15. So you need to multiply by 5 times, and this will actually give us 75. So the final answer is actually these two added up together, which is 60 plus 75, and we would get 135 as our answer. Okay, so now let's look at question 5. So for question 5, right, basically we are looking at solving this following equation over here, and we want to find the unknown, right, which is unknown m, and each of these unknown is actually a natural number. Natural number meaning it has to be a positive whole number, okay, in this case. So it can be a positive whole number. So you need to take note that the hint says that there may be more than one set of solutions, right? Okay, so we'll take that in mind. So the first thing you want to do is to, okay, find the unknowns, right? Okay, so let's say for this step, I want to find the unknown m by keeping m on the right hand side. So we have 3m on the right hand side, and I want to move everything else to the right hand side. So we have 39 over here, which is good, but we want to move the 4n over to the right hand side of the equation. Okay, so we have to minus away 4n. Okay, so the next step, right, is to remove the 3, right? Okay, how do we remove the 3? Just to have our m on the left hand side would be, we need to divide by 3 throughout the equation. So m equals to 39 minus 4 n over 3. Okay, so right now we just want to try out different values of n, right, to make sure that our answer for m is a positive whole number. Okay, so we will just try and cycle through some values of n, and let's see how it goes. Okay, so for example, you can try n equals to 1. So what happens when n equals to 1? You have m equals to 39 minus 4 times 1, which is just 4, and you divide this by 3, right? So what is 39 minus 4? 39 minus 4 is actually 35 divided by 3. So we can ask ourselves, right, whether 35 divided by 3 will give us a whole number in the first place. So you realize that it can't, right, because actually you can make use of 36 divided by 3 to give you a whole number, but not 35. Okay, so over here this is rejected. Okay, so you can see that where this is going, right, you have to quickly cycle through some numbers. So let's try n equals to 2 right now. Okay, so we have m equals to 39 minus what is 4 times 2, 4n, right? 4 times 2 would be 8. Okay, and this divide by 3. So what is 39 minus 8? You will get 31 over 3. So 31 is also not a multiple of 3. So this is also rejected. So with that, right, you realize that you need to try out different numbers. So we have n equals to 3 now. Okay, so m will be equals to 39, same thing. And we are looking at doing 4 multiplied by n. N right now is 3. 4 times 3 would be 12. And this would be divided by 3. So 39 minus 12, we will get 27. 27 divided by 3 would give us 9. So very good. So you realize that this is actually our first set of solutions. N equals to 3 and my m is 9. Okay, so we will basically run through some of these values, right? And you might realize that actually your next solution would be, what happens when you try n equals to 6? So when n equals to 6, your m would be equals to 39 minus, what is 4 times 6, you will get 24. So we divide this by 3, right? So 39 minus 24, we will actually get 15 divided by 3. And we know that 15 is actually a multiple of 3. So 15 divided by 3 will give us actually 5. So this is also one of the other solutions. Very good. And then let's move on again. So let's say you have tried all the solutions and you land up with the final one, which is n equals to 9. So we have m equals to 39 minus, what is 9 times 4? 36. So you will divide this by 3. So 39 minus 36 is just 3. And you divide by 3 again, you will get 1. Okay, so this, you realize that, okay, 1 is actually already a quite small number, right? So you realize that if you increase the value of n any larger, then you will no longer get a positive m value. Okay, so you realize that actually this can be all the answers that you have. Okay, so you just have to cycle through and get all the other answers. Okay, so you have actually n equals to 3 together with the m value of 9, n equals to 6 with the m value of 5, and the last one, n equals to 9, your m will be equals to 1. So these are your answers for this question. We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.